This is Solve It for Kids.
Hello, my amazing and curious friends. My name is Jennifer, the Dean of all things STEM STEAM, and this is Solve It for Kids, the science podcast that gives kids and families a peek inside the real world of scientists, engineers, and experts as they solve problems in their jobs using creativity, cooperation, and critical thinking. And now please welcome to the show my podcast partner, Galactic Space Geek, Jeff Gagne.
Hello, Jennifer, and hello, listeners. What an exciting episode we have today. Not only do we talk about space, we get to talk about one part of communicating with space that doesn't get talked about enough anymore.
Oh, that is absolutely true. So what problem are we solving today?
What is a radio telescope?
What is a radio telescope? This is going to be a very intriguing talk today, I think. Who is our guest, Jeff?
Our guest today, we both know her. She is the wonderful Sarah Treadwell. She is a science communicator at SpaceCase Sarah, and she's also a PhD student in communications.
Welcome to the show, Sarah.
Yay, thank you. Thank you for having me.
Oh, this is going to be so much fun because, as Jeff said, you love science as much as we do, so we're so excited. But,
yes.
I know. But, okay, so here's my question. I love science since I was a little kid. Have you loved science since you were a little kid, too?
Oh, you asked a big question right out of the bat. No, actually, I did not.
Really?
No, I really, honestly, was kind of big into English and music and the arts, and went originally to school for music. And then it was when I had my daughter, who is now 9. I'm sorry, I called her 8 earlier. She's 9. And when she was a baby, I was kind of flipping through TV wee hours of the morning, and I saw this TV show called Cosmos. And I was like, I don't know, what is that? And I watched the first episode of Cosmos, and without getting into too much detail, I did not get to be raised in a very science literate home. So there were a lot of concepts that I had no idea. The cosmic calendar was just, it blew my mind. And I was like, what else don't I know? And that sent me on this journey to learn as much science as I can. And I've been very fortunate that now I have found a way to both learn and work in something that I absolutely adore.
Oh, that's fantastic. Okay. I love your curiosity is what drove you. Yay. That's what I love to hear.
And you just said something right in the middle of that answer. What a great question. What else don't I know?
Yeah.
So my question for you is, what age were you when you started watching that? And what were some of the first couple of steps that you took to start learning more of what you didn't know?
Awesome. Yeah. So I will admit I was kind of late in life. I was almost 30. I was about 30 when I first learned that. No, actually, maybe a little bit younger than that, because I'm trying to do the math of my daughter. She's 9. I was in my late 20s. So I was in my late 20s, and I saw Cosmos, and I just was blown away by some of these concepts that I had never learned before. And then I just started reading books. I started watching different documentaries, nature documentaries. And then I got my first telescope. And that was pretty exciting for me that I got this telescope, and I started to accidentally do science communication. I didn't realize that's what I was doing, but I saw the moon and I was like, wow, this is incredible. I have to show this to somebody else. So I just started, anyone who was walking by in my neighborhood, I'd be like, hey, do you want to see the moon? And so kind of big, crazy story to it all. I was coming home from an astronomy event, and I got into a really big car accident. And I luckily didn't have my telescope in my car, but I realized in that moment that my life was precious and short, and that I needed to just pursue what made me happy. And that was science. And so the next day I was asking people how I could get into science. I specifically was going to try to go get a master's degree in biology.
Ah, that's so cool.
I know. It's a big story.
So how did can you tell us a little bit about what you do as SpaceCase Sarah and how
Yeah.
you got from there to
Got there from there. Yeah.
you're pretty big in the science communication area now.
So I started going to actually my local community college, which I think is sort of this, lesser known secret. It's a great way to start getting your education. It's affordable. And a lot of the schools that are 2-year schools like this, I think a lot of teachers are really great teachers in community colleges because they work really hard. So I started going to school and then the pandemic happened and I was like, oh no, what do I do? And so a friend of mine who was at the lab that I was hoping to get into said, well, hey, there's this great organization called Blue Marble Space Institute of Science, and they have some internships that they're putting online. Maybe you could do something there. And I applied for an internship with them called Communicating Earth and Space Science Topics. And I loved it. And so now I kind of joke with them, I'm the intern who never left because now I'm a full affiliate with them. I'm working on a book project with them. So I loved it. And I was like, this is what I want to do. This is great. So I switched my whole idea from biology to communications. And I've just been very, very fortunate.
That's fantastic. Yeah. And so people that don't follow you should. Absolutely.
Yeah. Well, and that's one of the things I really like as SpaceCase Sarah. One of the things I really want to encourage kids and moms and people with children is that you still are a full person who can still explore hopes and dreams and ambitions, right? Just because you're a mom doesn't mean it ends and you can't follow your passion.
Absolutely.
And kids, I think, too, get so stuck on this, like, what should I be when I grow up? I had no idea. I still kind of feel like I don't have any idea. And I think it's okay to change your mind and say, hey, this isn't working. I'm going to course correct and I'm going to go start trying this now. And I think that that's okay. And we need to encourage kids to do that more.
Yes.
Nice. So with that, since you jumped into the Blue Marble Space Institute, can you sort of explain a little bit about how you were working that first project with them and how that helped you grow into what you're doing now?
So many of my stories, I'm sorry, they're going to be like, I was in the right place at the right time. I don't know what to tell you. But so the cool thing about Blue Marble is that they partner with NASA to kind of connect you with different NASA researchers and scientists. And so like I got to interview a bunch of really cool people right away. I interviewed Carl Pilcher, and he was one of the scientists who kind of helped founded NASA astrobiology. And he discovered the winds of Neptune, like,
oh my gosh,
as one does.
Cool.
And this was, 2020. So the Perseverance rover was launching at that time, right? So I built this whole project around the launch of Perseverance. I was so excited about that. And by a series of very random circumstances, ended up getting reached out to by Dr. Zurbuchen, who was the head of the NASA Science Directorate.
We've had him on our show.
Have you? Yeah, he's so nice. Yeah, he reached out to me.
Dr. Z.
Very cool. Dr. Z reached out to me and was like, I would love to do some like podcast kind of live stream things with you. And we really connected on some of our background stories. And so these successes just kind of kept building on each other. I got selected then shortly thereafter to do a Mars analog astronaut mission at the Mars Desert Research Station.
Oh, wow.
And then while I was at that station, I learned that I got accepted to sail on the JOIDES Resolution as the onboard science communicator. So it just kept snowballing and building.
Fantastic.
And
That's really awesome.
Yeah.
So, and as long as we're talking about all of the things, so the question is, what is a radio telescope? But that actually kind of fits into your whole journey, because where did you just come back from, Sarah?
I just came back from Chile. I was an ambassador for basically the NSF and the Ambassadors in Chile program that the AUI group holds. And so they select a handful of people from the United States to go to Chile, and you get to visit all these telescopes that the NSF owns high up in the mountains in Chile. And then you get to come back and share about the science and all of the amazing people and places that these telescopes are at.
Yeah. And specifically, which one did you go to?
Oh, well, we went to a lot, but
because I was talking about I'm going to say this wrong. How do you say that? Atacama? How do you say that?
Atacama, yeah, the high site. We went to Alma. So Alma.
Oh, okay.
Yeah, Alma is the consortment of radio telescopes that were very, very critical in taking that first picture of a black hole. If you remember when that came out, and that was super exciting. Yes. So they have pictures all over their offices of this black hole, right? They're like, we were fundamental in taking this picture.
Wow.
So
Very
yeah,
cool.
yeah. The high
Okay,
telescopes are really high.
Yes. So what is a radio telescope?
Yeah.
Yeah. And that's, I've spent some time thinking about how to explain this because it's a hard concept. It really is. When we think about telescopes, we think about the visible light and what you can see with your eyes.
Yes.
But light moves in waves, just like, a ripple in a pond. There are different waves and they go at different frequencies. And some of those we can't see, but other animals can see lots of different types of light, like snakes can see infrared and, bees and birds can see ultraviolet. Humans, we're a little bit more limited in our range. Thanks, big brains, for not giving us that ability. But in space, all this type of light emits in these different wavelengths, some that we cannot see with telescopes that use our eyes. But radio telescopes can pick up waves of light that we cannot see with our eyes, which is pretty neat. So radio telescopes can work day or night. They're up there really high up, picking up radio waves from different everything out there in space. And it can give us so much more information that we can't get just with visible light too. Like it can tell you what the temperature of something is, or, it can cut through cosmic dust and you can see through things to see what's inside, a dusty cloud in space.
Wow.
So radio telescopes are kind of, science to me all works together like pieces of a puzzle. And so the radio telescopes complement the James Webb telescope up in space that complements, it wasn't just radio telescopes we got to see in Chile. We got to see some of the most important visual telescopes as well. And they all kind of work together, right? To piece together data to give you these amazing pictures and information about what's out there in space.
So what is so special about radio telescopes? Can they see farther than other telescopes from Earth?
It's just that they can see other types of information that we can't see with our own eyes, right? So think of the Pillar of Creation, which is one of the most famous, pictures that James Webb has taken. That's actually a bunch of dust and stuff that an optical telescope, you can't see what's inside it. But with a radio telescope, you can see all those baby stars getting born inside it, and those nebulas. And it's actually kind of tricky. I guess the con to radio telescopes is radio waves, because they move at such a bigger wave frequency. So there's more space between that high point and that low point. There's a big wave. It makes it a little bit harder for them to pick up signals really far out because it's bigger waves, peaks, and so that's why they stick them up really, really, really high to get as clear of a signal as they can possibly get.
Yeah, that makes sense.
So can you describe what a radio telescope looks like? Because maybe not all of our listeners have the right picture in their minds.
Well, I actually think if you say radio telescope, it's kind of one of the things that most people actually do think of, because popular media is very kind of fixated on those big dishes with the kind of like a satellite receiver that you'd have on your house, right?
Yes.
Like you're very familiar with that, what that looks like. And so then you have movies like Contact, and anytime there's an alien movie, you always see radio receiving telescopes because they're big dishes with sort of, poles that kind of come up to the center. And then there's a hole in the middle of the dish. Whereas a big optical telescope is a big mirror. And so it's actually not like a telescope that's on a tripod. It's like a giant thing inside a dome. So I don't think people are as familiar with those telescopes as they are with radio telescopes.
Yeah, and they're huge because we just watched Contact the other day. The movie, which is old, which if people haven't seen that, it's really good, and it lasts still.
Yes,
but they're huge.
They are huge.
These are gigantic, and there's multiple ones. Can you explain why there's more than one sometimes in a place?
Yeah, it's just a lot of ears. It's a lot of them all kind of point. And then there's a couple of reasons that there's so many. There's, first of all, it's a lot of ears working together. That's the best way to describe it, to gather as much data as they can. And then they're also owned by different countries. So Alma at that high point has 66 telescopes. And it's oh
my gosh.
Wow.
It's a very odd percentage, but it's almost half and half is the United States and Europe. And then I guess right at the last minute when they were building it, Japan was like, wait, we want to come too. So then Japan has a small little handful as well. And you can see the difference between them. They're built stylistically different. And actually the Japan ones are tiny bit smaller.
Do they all work together and
They
share
do all work together.
information
Yeah,
and
they
stuff?
do. So they
that's
build,
cool.
they all collect the information. And so, well, I'll just explain Alma really quickly so you can get a better visual of what this is like. So there's a base camp, and that's where all the offices are. That's where everybody sleeps.
Okay.
There's even like a big outdoor field that's covered by a dome. And then that's at like 9,500 feet. And then there's the high point, which is at like 16,500 feet.
Oh, wow.
And so you go up to the high point, and then there's another small building that's actually fed with oxygen. So you don't have to wear oxygen because you go up so fast, they give you oxygen to wear. The high point has where the computers are also to gather all that data. And they told us these rooms that have these computers were the equivalent of 3 million laptops.
Whoa.
Wow.
That's a
Yeah.
lot. That's a lot.
Yeah.
Wow.
And I guess when they collected the data
a lot of computing power.
that is a lot. When they collected the data for the black hole, it was like they had to send down cars, like multiple waves of cars just carrying down whatever it was that brought the data back down to base camp. I don't know. It's just insane.
Oh my gosh.
What makes radio astronomy with radio telescopes so important?
I think it's really important because it lets us see more, right? It lets us see more than we could ever possibly see with our own eyes. You know, light travels at a very finite speed. So we're always going to be bound by the speed of light, obviously.
Yes.
But we can get a lot of information extrapolated by using all the ranges of light, not just the visible light. And that information gives us, you know, so much more data to understand how the universe works, how the world works. I mean, one of the telescopes we got to see, and I wish I could explain the science succinctly, but I can't. But one of them, it maps dark energy. And it's one of the most heavily used telescopes that they have out there. You know, we're trying to understand all of these things that some of it we don't even know yet. Like, we don't really know how dark energy works and how that will come into play in the story of the universe. But we want to learn, right? What else don't we know?
Right.
Yes. So is the reason that they're so high up is because I know it can be difficult to see through the atmosphere with the telescopes. Can you talk a little bit about that, and also kind of like why we put the James Webb out
into
there?
Space? Yeah. Well, Chile is a really, really special place on planet Earth. It is where you can get the best skies for all types of astronomy next to Antarctica. So this is the driest place on planet Earth after Antarctica. And the reason is because you have the Andes Mountains on one side, and then there's a low kind of pressure system that keeps moisture over the Pacific Ocean. So it's like this tiny little strip of land that's just dry. And then it also has high mountains. So it's a really great spot to put these telescopes. So the atmosphere is still going to be there, but you don't have all the moisture going up in the air. Okay. And so that gives us a great view of the sky. But then obviously, yes, sticking something in space, then you don't have to worry about the atmosphere anymore, right? then your main culprit is, you know, all the other things that make space so hard, like the radiation from the sun, and it's hot and it's cold. But again, they all kind of work together to give us this great grand picture. And Chile is just like the best place. It's so cool. And it's so dry. It is so dry.
It sounds like something I would not be good at as a Floridian, living in humidity all the time.
Probably not.
So while you were there, you mentioned that they were very instrumental in working out that data for the first image of the black hole. While you were there, can you describe a project that they were working on? Like, what were they collecting data about?
You know, we asked them that. And here's one of the things I think that was interesting about the experience. These are the most scientifically active and used telescopes in the world, to the point where it's almost like you kind of wanted to make sure you're staying a little bit out of the way, because you know, these scientists, they win time to use these telescopes by proposing grants like, you know, telescope time, years in advance. So like, you know, they're there to do the work. I also can't 100% share everything that they were working on, because sometimes that's also a little bit, you know, like they don't want to talk about it. But there were a lot of scientists doing a lot of work. And like I said, that one telescope in particular that looks at dark energy, that was a bopping one. Like they use that one a lot. The ALMA one, they did explain to us a little bit like how very difficult it is to get time to get your project to be able to get to use these telescopes. And so they weren't even really aware that the people, they were like, I'm not even sure who's on it right now. But the kind of interesting thing about it is that there's really no one up there at any of these telescopes. There's the people who are running them and the staff, you know, and the support staff for the engineers and stuff. But the actual astronomers are often remote somewhere wherever they are based in their, you know, home university or down in Santiago, which is the main town in Chile. Yeah, there's actually no one like, we all have this romantic idea, right, of an astronomer sitting in a dome and staying up late and looking through it. That's really not how it works.
Well, okay, so we did talk a couple of times about the black hole, but for those of us who are listening who may not know, can you talk about how significant this discovery was? I mean, I can just imagine. I mean, you say everybody wasn't there, but I would imagine there are a lot of people cheering when that image finally came through.
I can't even imagine what it would have been like to be in that room when it finally got all pieced together, because it wasn't just ALMA. ALMA was probably the most important observatory for it, but it was all around the world, different observatories all around the world collecting data to get this picture of a black hole that's in the center of our universe. The thing that is exciting to me about the black hole, and what I think is very significant, and maybe not everyone would agree, but for me, is that Einstein predicted that there were these black holes, right? But no one had a picture. We just knew by the math, by what we can measure in our universe, there should be these things. And kind of fun factoid, but one of my favorite movies of all time is Interstellar, and they did not have that picture of a black hole yet for Interstellar. And so based on just real scientists' predictions and estimations of what a black hole should look like, they built one for that movie. Then we got this picture and it looked so much like what they had in the movie. And I was like, that is so freaking cool, right? That you can use science to make an awesome movie.
Yes.
And then it turns out to be real. But I think, what was so exciting about it is kind of that confirmation, right? That like science works, math works.
Yes.
We knew it was probably going to be out there. And lo and behold, we finally were able to take a picture, and there it was. And I mean, they've taken a second one since then. And so for me, at least, I mean, I'm sure scientists will give you many answers of why this is significant. But for me, I think that that's just that confirmation that science works, right?
Yes.
The scientific process works.
Yeah. And it's an amazing image. So those of you that haven't seen it, check it out. Cool. And we'll probably link to it on our website, solveforkids.com.
Yeah, super cool.
So I would like to ask, before Jen moves us on, you have been doing science communication for a while now.
Mm-hmm.
We talked a lot about how you got into it, and that led to another thing and another thing and another thing. So it's been cool thing after cool thing after cool thing. And we just talked about this cool thing that you were doing. How do you think differently now about science communication than when you first got started and said, hey, I really like this. I want to figure out how to do it?
Ooh. I think when I started, I had a lot of imposter syndrome, right? Like I did not really feel like I should have been there. I am a kid from Elkhorn, Wisconsin, who studied music and just happened to fall in love with science. And who am I to speak to this? And as I have continued to move on in each experience, I have come to learn that I might not be the biggest expert on black holes or how a telescope works in the room, but I am very qualified to learn as much as I can and share it back to people in an enthusiastic way that not everybody has that gift. And so I've learned to grow in myself as a science communicator that I have a job to share really cool science to as many people as possible. And I am very qualified to do that. But like at the beginning, you definitely, imposter syndrome is a very real thing. And it, definitely can still creep up onto you even as you continue to grow in your career. I would say that's the biggest change. Yeah.
Even if you've written 50 books, you can still feel that way. Yes.
Yes. So that is definitely it.
But sometimes I think those of us who just find science cool, but maybe not completely understand it. It's a great way to help people, think about it in different ways, and we can approach it in different ways. And I think that's what you do. So before we get to your challenge, I want you to tell everybody how they can follow you on social media.
Perfect.
Absolutely.
Yeah, I am SpaceCase Sarah, and I have grabbed every handle on every social media platform that could be possibly using that. So if you go to anywhere, Facebook, Instagram, TikTok, X, I am SpaceCase Sarah. So you just type in SpaceCase Sarah and you will find me there. And I also have a website, spacecasesarah.com.
Yeah, which is really cool.
You will not be sorry you did.
No, you make awesome videos and lots of things right now. You're teasing everybody about things that are amazing things that are going to happen. So everybody check that out. Okay. So now we are at the time in our show where we ask our guests to give our listeners a challenge. What is your challenge, Sarah?
Well, my challenge, and it's more of a thought challenge than anything else, but, is do you think it's possible to use a telescope to see the far side of the moon, otherwise popularly known as the dark side of the moon, but it is the far side of the moon?
Yes.
Do you think that is possible?
Should we give them the answer, or should we make them go to the website and take a look? What do you think?
I'm kind of intrigued for people to look at and check it out themselves. And if so, what does that look like?
Oh, okay.
And,
I like that.
How does that look compared to, if you're a science geek, I'm sure you've maybe had an opportunity once to look through a telescope at the front side of the moon, right? The side that's always facing us. So
yes.
Yeah, I'd love to hear how that might, if it is possible, how those contrast.
Okay, so everybody go out and do that. In fact, the next time, Jeff has access to a telescope. We do not have one yet. This is my birthday's coming up, hint, hint.
Oh, wink, wink.
But this would be awesome. So everybody go out and see if you can see the far side of the moon. And if not, you know what? Like Sarah was talking before, maybe use math to figure out if you could or something like that. Oh my gosh.
Mm-hmm.
This has been so much fun. I have learned so much about science communication and radio telescopes too.
Right.
Thank you so much for being on Solve It for Kids, Sarah.
Oh, thank you for having
Sarah.
me. Thank you.
All right. We knew that was going to be a fun chat, and we say it all the time. We could have just kept on talking to her because there is so much about communicating with space that is super cool. What do you think, Jen?
Yes, absolutely. And, I think radio telescopes are so amazing. Also because I'm doing a lot of research on them right now. To me, it's just crazy that we can talk to these spacecraft that are so far away and figure out what's going on. And I love Sarah's challenge here. I think this is going to be a really intriguing thing to see what people think about this. Right?
Absolutely. Because this is a direct connection between what we just talked about in this episode, radio telescopes and how they work, with, do you think it is possible to use a telescope to communicate or see the far side of the moon? Ooh. I think we are going to get a whole lot of listeners doing that little head scratcher, and this is going to get them thinking.
Yeah. Well, we hope it gets you thinking. And if it does, we would love to hear from you. So check us out on our website, solveitforkids.com, and also our social media. We are at Kids Solve at Facebook, X, and Instagram. And don't forget to go back to that website and find all about Sarah and follow her at SpaceCase Sarah. She is amazing and has all of this cool science stuff that she puts out all the time.
Yes, you will not be sad if you start following SpaceCase Sarah. She's awesome. Until next time, you'll hear Jen and Jeff on the Science Podcast for Kids and Families. Solve it for kids!